Okay, we are going to practice what we learned about equivalent graphs and making their equation using the COP. The instructions say to determine if the table or graph shows an equivalent relationship, and they even tell us how to do that. They say we're going to be looking for a straight line and a graph starting at the origin. If there is an equivalent relationship, if you say yes, you have to write the equation. If not, you won't be able to write the equation and you could leave it blank. So those will be exciting problems because then we get to do less work. Let's look at what the table is asking. So I can see we have a problem number and then we have a problem. Sometimes they're going to give me a table, sometimes they're going to give me a graph, sometimes they're going to give me both. And I have to find the independent variable and dependent variable. Remember that the independent variable is x and the dependent variable is y. It also might be helpful to remember that on a graph, x goes at the bottom, y goes on the side. Those are both going to be important clues. Equivalent, this is where you're going to check the two things. You're going to check, is it a straight line? Does it start at the origin? And you're going to say yes or no. For the let statement, you're going to define your variables based on which is the independent variable and which is the dependent variable. So remember, again, independent variable is x, dependent variable is y. For the equation, we're going to use y equals COP x. And if you want to remember how to find COP, that's when you do y divided by x. So we're going to practice that together. All right, so looking at the problem first, I see that they've given us a table and a graph, and we could use either of those to help us answer some of these questions. For the independent variable, I'm either going to say what comes first in the table or what's in the x position in the graph, and that is time. For the dependent variable, I'm either going to say what comes second in the table or what's on the y-axis on the graph, and that's going to be heartbeats. All right, equivalent. So let's see. Is it a straight line? Yes. Does it start at the origin? Yes. So yes, it is equivalent. Awesome. If you didn't have the graph and you only had the table and you couldn't check if it was a straight line and started at the origin, what you would do is reduce all of these ratios to see if they're equivalent. So 4 and 6, if I divide them by 2, that's a 2 to 3 relationship. So that's dividing by 2. 6 and 9, I could divide them both by 3, and it's also 2 to 3. 10 and 15, I could divide them both by 5, also 2 to 3. 12 and 18, I could divide them both by 6, also 2 and 3. So that's another way you could see that it's equivalent. So it's equivalent for both of those reasons. For the let statement, whatever x is going to be the independent variable. So let x be time, let y be heartbeats. Now the equation. I have to start by finding the COP, which means I have to do y divided by x. It doesn't matter which point I pick. I'm going to pick a random point. Let's do 10 and 15, but I could have picked any of them. Y is the second one. It's the dependent variable. 15 divided by 10. Let's see, I could divide them both by 5. And I get 3 over 2, which is 1.5. So the equation is going to be y equals 1.5x. All I've done is I've found the COP and I put it right in front of the x. That's all there is to it. See if you could do the second one. Pause the video, come back when you're ready to go over it. All right, hopefully you're ready to go over it. For the independent variable and the dependent variable, they haven't given us any labels. So the only thing I can say is that the independent variable is, need to stick with my same colors. Independent variable is x, and the dependent variable is y. So that's all I can do. There's no other labels. Now, are they equivalent? Is it a straight line? Yes, it is a straight line. Does it start at the origin? No. So since it doesn't start at the origin, the answer is no. It has to start right here. This one doesn't. That means I don't have to do anything else on this problem. I'm done. All right, try number 3. Pause the video, unpause when you're ready to go over it. All right, let's take a look. I know that whatever's in the first column will be my independent variable, and whatever's in the second column will be my dependent variable. So oats and almonds, and you can say cups of, it doesn't matter. So next I want to check if it's equivalent. That's what this heading is. There's no graph, so I can't check if it's a straight line or if it starts at the origin. Not an option, there's no graph. So I have to check if these ratios are equivalent. First ratio, 3:1. All right, that can't be reduced. Second ratio, I could divide them both by 2, and I get 3:1. Okay, we're in good shape so far. Could divide this one by 3, and I get 3:1. So far, everything's equivalent. Could divide this one by 5, 3:1. And I could divide this one by 10, 3:1. Since all of those numbers gave us equivalent ratios, we could say yes. X is going to be whatever our independent variable was, or whatever's first in the table. It's the same thing. Y is going to be the dependent variable, or whatever's second in the table. So let X be oats, let Y be almonds. All right, the equation. First thing I need to do is the COP, which is Y over X. Remember that Y is the second column in the table, X is the first column in the table. So I can take any one of these numbers in yellow and divide it by the corresponding number in pink. Well, I'm just going to take the first row because that one I won't have to reduce. So Y is 1, X is 3. Can't reduce anymore, so the COP is 1/3. Now I need to put it in this spot. Y equals COP X. I just put the 1/3 right there. We're done. All right. Pause the video, try number 4. Unpause when you're ready to go over it. Okay, hopefully you're ready to go over it. This time the columns go across instead of going up and down, but that's okay. We still know that the first column, X, has to go with the independent variable, and it has to go with the let X later. The second column, Y, goes with the dependent variable, and it goes with the let Y later on. They don't tell us what X and Y are, though. So all we can say is independent variable is X, dependent variable is Y. We can even skip ahead and put that in the let X and let Y spot if we want to. That's all the information we have for it. This first column is, are they equivalent? Well, there's no graph for us to check, so I have to check all of these ratios. First one is 1:3. Second one is 3:9, but I could reduce them both by 3, and I get 1:3 again. Second one is 8:24, but I could divide them both by 8, and I get 1:3 again. Last one is 10:30, divide them both by 10, 1:3 again. So yes, these are equivalent. Lastly, I have to find the COP. So to find COP, I have to start by doing Y divided by X, and I could take any one of these. I like using small numbers, so I'm going to work with the 1:3. The Y value in 1:3 is the 3. That's the one in the Y column, the second column. Or I guess it's second row in this case. X is 1. 3 divided by 1 is 3. We're done with that. Now I have to do Y equals COP times X. and just put that 3 there. Y equals 3x. All done with that. All right, let's try one more together. Number 5. So I know whatever's on the x axis, which is just the letter x, they don't give us any more information, goes with independent and let x. Whatever's on the y goes with dependent and let y. So the independent variable is x. They didn't tell us what x is, so let x be x. Dependent variable is y. They don't tell us what y is, so let y be y. Since this is a graph, we're checking 2 things. We're checking, is it a straight line? And does it start at the origin? Yes, it does. Pause the video, see if you could finish this one up, and then come back when you're ready to go over it. All right, so the COP is y divided by x. So we have to take any one of these points. I like this point. You can't use 0, 0, unfortunately. The y is going to be 4 and the x is going to be 2 because that's what axis they're on. So I need to do 4 divided by 2, which is 2. Now I have to put that into y equals blank x, and that's going to be a 2. So the equation is y equals 2x. All right, please finish